Welcome back, guys. And today, for this topic, sorry, for this video, we try to finish all the chapter 10. The next one, we're gonna move to chapter 11. Okay. So the 10F is the maximum and minimum problems. Basically, this one is okay. Now let's look at these problems. Example 23. A farmer has sufficient fencing to make the rectangular pen of per meter 200 meters. What are the dimensions will give an enclosure over the maximum area? So essentially they tell us there's a fixed length of the things we can use, which is 200 meters, and they ask about the dimension stuff. Dimension essentially means the area, right? So because we have 200 meters and we have two widths and two lengths, so each of them will be x. If we make the length is x, then our width is going to be 200 minus 2x over 2, so which is 100 minus x. So our total area will be x times 100 minus x. So this is the x, 100 minus x, and 100 minus x. Okay. And finally, the maximum value of the a will be occur at derivative, because our graph gonna look like the hyperbola, but the highest leading coefficient is just -1. So then exactly we got the 50. So our maximum area will be 50 squared, which is 2,500. So for next one, example 24, it's a bit tricky because they suddenly involve with three unknowns, which is x, y, and z. But essentially we have the relationship with x and y. So again, for our objective functions or for our aim or target, it's become x plus 8 times x to the power of -4. Okay, because x to the power of 4 times y is 8. That's why my z is this one. So I can express my z in one variable. That's the key idea over here. Okay, we will express our unknowns or our equations only into relationship with one unknowns, then it's become much easier, and we can do derivative analysis, because currently we don't know what's two variable gonna be change, or what's gonna be two variable change to influence or impact our one variable changing. So that's why we have to do two variable, sorry, we have to demolish or like to convert it into one unknowns, then we do the differentiation. Okay, makes our life a bit easier. So after the calculation, we got my x equal 5, sorry, x equal 2, then I plug back, get my y value, and I can get my minimum value in such case. Okay, and essentially 25, same thing, because we got the cylindrical tin or cylinder. So the surface area and volume will be given, but again we involve with two unknowns, which is r and h, because essentially remember pi is just random number, okay, and it's approximately 3.14. Just remember it's a constant, so it's not affected with the derivative. Okay, just remember to times it. So once we got expression for our h, then I can plug in equation 2 to get the volume only depend on r. Okay, then I use derivative to get the values for my volume. Done. Okay. And 26, 27, same thing, but just make sure you need to change, or make sure you read the question carefully to get the equations and then to find the derivatives. Okay, that's all use the same strategy. And just look at the 30, and 30 is pretty interesting because it involved with exponential, so it's linked what we have learned in chapter 5, right? So just make sure you know how to do the derivative and how to calculate by using CAS, or calculate the exactly value by using hand. Okay, So hand calculation and CAS calculation are both pretty important, tag-free, tag-active. And now this is another important concept I'd like to introduce. They ask us to find maximum rate of increase and maximum rate of decrease. So for rate of increase or the rate of decrease, it's basically just one thing, rate of change, which we discussed in 10B, right? Rate of change, average rate of change just y2 minus y1 over x2 minus x1. And instantaneous rate of change just derivative. So they ask us what's the maximum value of our derivative. So let's look at the logical. First, I got my fx, so my f dash x is to find this guy's maximum or minimum. But now I'm asking you this guy's maximum or minimum. So which means with derivative again, right? So if I make it as gx, essentially I just find gx derivative. So derivative, the derivative, okay? It's basically second derivative. So, but in our math method, we never telling you this one is second derivative. Okay, it's not required. I mean, although they have the one star later, I will show you, but one star for the headline. But again, you are not required to know this one, but you have to read carefully. Rate of increase and rate of decrease is dy over dx. Maximum value, again, derivative. That's why I'm saying this is second derivative according to the original function. Okay, so be careful with this part. Derivative, derivative. Okay, and again, this one you suddenly realize the second derivative and points of inflection. But since there is a star over here, this concept is not examined, so they're not gonna really tell you what's the name. Over here in example 31, which is this guy, if you have time, you can look at this one. And we use the derivative of the derivative called second derivative. But this concept, again, is not required for math method. This material is not included in study design, which means they're not gonna test you. But again, second derivative, the name, they won't test you, but they can ask you to find the second derivative by indicating like, I want you to find the maximum rate of change, increase, or the maximum rate of decrease, okay? Again, this concept name you don't need to know, but you need to know how to find the maximum rate of increase or the maximum rate of decrease, okay? This is the 10F. And for 10G, it's just a family of functions. Again, this one is basically the hardest part, but because they involve again with the unknowns or the letters we don't know, like literal, such as in this case, fx equal x minus a squared times x minus b. So we don't know anything about a and b. We don't know, we just know they are the positive constant and b is greater than a. So my final answers will include a and b or everything, you know, but instead of the numbers we are familiar with. So that's why it's pretty difficult sometimes for us. And also it's involved with a lot of manipulation and algebra. It's since they are not real numbers, so you have to deal with b and a in all the equations. And this one is normally give you at the beginning, and then later they give you some special numbers to plug in to get the final answers. Okay, so for 33, same thing. Our turning point involved with A and B, and this guy, they ask us to find A and B in terms of C. Again, it's testing you guys the calculation skills. Okay, so this is 10G, and all the concept or all the method used is exactly same as we're dealing with real numbers, but the only difficult thing is how do you fill the gap, and how do you really make yourself confident about dealing with these variables like A and B in this case. Okay, so this is all about derivative. Essentially for this chapter, the first important thing is tangent line and normal line. You need to know how to do it. The second one is stationary point and its type and maximum and minimum problem. And the last part is we covered over here, like the maximum rate of increase or maximum rate of decrease. But again, just remember the differentiation can also apply in physics, such as motion. Okay, hope my video is helpful, and if you feel it's helpful and useful, just click the like button and share with your friends. And next video will cover about the anti-differentiation, which is in chapter 11. Okay, thanks for watching guys, and see you guys for the next videos. Bye bye.